This is Essential Web Security. I'm used to having about an hour to give this and running out of time, so I have slashed my slides mercilessly to try to make it fit in 40 minutes and make sure it's the essential, most of what you need to know, web security. There's much more. You can spend hours, days, weeks learning about stuff, but I'm going to cover a lot of the highlights. Quick introduction. Hi, my name's Eli. I'm one of the owners of PHP Architect, if you can't tell from the bright orange clothing. We produce a monthly magazine, do online training, in-person training, run conferences, make books, etc. If you want to find me later, I'll be around all day. I actually have a couple of our print magazines to give away if folks are interested in touching them or taking one away. They are very nice to fondle the covers. Come find out and you'll see why I say that. But that's not what you're here for right now. Right now you're wanting to hear a little bit about security. And often when I've gone to places and talked about security, this is the number one question I end up hearing. It's like, yeah, do I really need to hear about this? Or do I need to worry about this? Like, I run this website for, it's just me and a couple people, and we've got like maybe 100 people who come to our website. Or maybe it's even an internal website. I make an intranet, and we trust our own users. I don't really need to worry about this, right? No, you need to worry about this. It doesn't matter how big you are, how small you are. It only takes one person. And let me just say, there are a lot of really bored high school kids with nothing better to do than to try to find a random website and find their way into it. And even if you're making an intranet, it's important to have security because people can accidentally hack themselves without even realizing it at times, or hack your own website. So you need to protect users from themselves as well as protect everyone else. One thing that I do want to point you to, there's a great online resource. It's the Open Web Application Security Project, owasp.org. It is a great place to go. It is one of the best places to learn about any new attacks that come up and get solved and how to solve them. One thing I'll note is a lot of the information in this slide deck are attacks that have been around for years or decades. The problem is there's still a problem. Everyone still needs to know how to fix them. A lot of the newer attacks that keep coming out are now very esoteric and often a browser bug really in the end, and are getting fixed by browsers, which is great because we as programmers don't have to worry about it. Yay! One caveat I like giving when I give OWASP though is it is a wiki. All the members of their project can open edit all the information there. So information about attacks and various attack vectors that are on there, awesome, great, important stuff. The solutions that are sometimes given, take with a grain of salt. For example, if you go, the last time I checked, hopefully this has been fixed, but if you went to the PHP quick sheet of how to do PHP security, and like the number one line on it was, don't use PHP, you idiot. So, grain of salt when looking through their solutions there. So, let's actually talk about some of these various attack vectors here. So first of all, I want to talk about injection attacks. And hopefully you already know about the most common of these, which is SQL injection. All right? SQL injection is the user having the ability to send data that is interpreted by your SQL engine. All right? So for example, and I should pause here at the moment and say, I'm going to be talking with a lot of how I'm presenting and a lot of my code examples. I'm going to be talking about sort of the core PHP way of doing things, because I do think it's important for people to understand the underlying bug and the underlying issue and to understand the fixes to it. I did specifically go through, and where I could, I did add in the, and here's how to fix this in Cake slides, so we'll get to those as well. So the security hole is simply taking information from the user, such as in this case, we have we're asking user for their name and password, and we are taking the data raw from the post variable and trusting that and putting that into our query, right? Now, if somebody comes in and says, they send their name in as quote or 1 equals 1, semicolon / what happens to that query? It becomes where name equals blank string or 1 equals 1, semicolon, comment out the rest of this equal. So I actually have a live, that's not what was supposed to happen. Let's go this way. There we go. I have a live example of this I can show you real quick. So for example, I have this simple little login page. This is actually running off of a local database. So I can try to come here and say login is Eli, password is something, I have no idea. No, I really don't want to save that. Error logging in, right? Because I had no idea what my password is on here. I bet I could guess what I made my password if I was doing this right. No, really, I don't want to do that, Safari. Thank you. All right. But I can't log in. But if I came in here and did the quote or 1 equals 1, semicolon slash flash, I don't even have to send in a password. I am now logged in. Now, I happen to get logged in as ELIW because that was user number 1 in the database. Because what that select became is it became a select the entire table. I used the first row of it. I became the user number 1. How many people's user number 1 is an admin user? You could also log in as anyone by just simply saying, oops, I need a quote in there. So I would like to log in as Beth. I am now Beth, simply because that, when put into here, becomes select star from users where name equals Beth in the query. All right. So how do you protect yourself against this? There are 2 solutions. All right. The best and proper way is to use prepared statements. All right, and it's the highly recommended way. So with a prepared statement, you end up making a query like you see on the top here, where you're saying select star from users, where name equals question mark and pass equals question mark. The question marks are a way you put placeholders in the query to say, here's where I'm going to give you data. There's also ways to do name parameters where you do like colon name, colon pass. And then you execute that query, handing it the data. By doing this, every SQL engine out there now looks at that first statement and it understands now this is the query, here's where user data should be. I should never interpret anything else put in there as anything but user data. All right. The other way of doing this is by escaping the data from the user. The old way, and do not ever do this, was using add slashes, because it doesn't actually work all the time, thanks to character sets nowadays. There is, if you happen to be using PDO, there is a quote that you use. If you were going very old school MySQL, there's MySQL real escape string. In Cake, however, Cake does do a lot of this for you, which is one of the awesome things about Cake, right? If you're using the ORM features, it's taken care of for you, don't worry about it, all right? If, however, you're doing raw queries, you can do prepared statements. I have the example up there now that basically you can do a fetch all, and again, put the placeholders, and then pass it in an array. By doing that, again, the SQL engine understands that that data is meant to be data only. It is not ever to be interpreted as part of the SQL statement itself. There are a lot of other types of injection. I don't really have the time today to go deep on any of these. If you want to talk to me about it over lunch or later, come grab me. I'm happy to. But command injection is the user being able to inject code directly on the command line. If you're not using system or backticks, then you don't have this problem inherently. Unchecked file uploads, people being able to upload files and you not verifying that they did, you were asking them to upload their profile image. But did you check that it wasn't an actual executable instead? Did you check it was really a photo that they uploaded? And there's some really esoteric attacks that can happen with that as well. And code injection. Code injection is the user giving you something that you then interpret as PHP code. This only happens if you are using eval. Remember the one most important rule. Eval is only one letter away from evil. That's for a reason. Don't do, okay. All right, so let's move on to some session security. First off is session hijacking. All right. Session hijacking is when one user can become another user by subsuming in some way, shape, form that user session. When you're talking about PHP or any framework written on top of PHP, sessions are always handled by handing back some type of session ID to that user via cookie, via HTML5 data storage, via a widget in the URL. And then that user comes back saying, here was my session cookie, this is still me. And by default, PHP goes, oh, hey, thanks for coming back. I knew who you were, and assumes that that's all correct. All right? There's a number of things to do to make sure that you protect people from this. Because at its simplest, if you went and just wrote a raw PHP file, and you did a session start at the top of it, and you did some stuff, and that was it, anyone who somehow made a predictable or guessed or anything else, the session ID for that user, could go to their browser, say, my session ID is this, contact that server, and boom, they're now that original user. All right? So first off is session fixation. This is if I'm able to give you a session ID that you then send to the third-party server, I know what your session is because I gave it to you. The simplest way that this would happen is back in the old days of PHP when no one trusted cookies because cookies were evil, awful things. And the idea of an HTML5 data store didn't even exist. And so sessions were always handled via the URL. And you would get these question mark PHP session ID equals and the number. So what that meant was I could on my website provide a link to like, hey, go visit PHP Architect's website. It's really cool. And in that link, put a session ID. Now when someone clicks that link from my website and goes to PHP Architect's website, they are using a provided session ID. Now that session was probably not used before that. So PHP goes, oh, hey, it's a blank session, lets the person log in. They now have a logged in session that I have the ID for. And I now, if I was smart and did some other logging that would like send me an SMS when someone did that, I now know someone has gone and used my trap I left, and I can walk in and say, oh, actually, I'm ABC123, and I'm now using that user session. So the simplest way to fix this is it's right into the PHP INI, is simply don't use URL cookies, but more importantly, don't allow them to be used. By default on lots of PHP installations, I believe if you just go get the core PHP installation, it does not do this, but a lot of Unix implementation versions have it so that session cookies in the URLs are not the default, but they are still accepted. So while you'll be passing cookies back and forth, if someone uses it in a URL, it'll go, oh, hey, a session ID. I will use that. So you want to set these three specific variables in your PHP INI. You want to set session use cookies equals 1. You want to say session use only cookies equals 1, which is what actually turns off the get variables as well. And this will come into more play more, there's another setting you should do called session cookie HTTP only equals 1. What that actually does, and that was added in later versions of PHP, is whenever you're setting cookies, it's a JavaScript standard, there's a way that you can set a flag to say this cookie should only ever be able to be read by the server, it should never be able to be read by JavaScript. All right, so that helps protect you against people doing JavaScript attacks like I will show you in a minute that would actually read someone else's session ID in. The other thing that you should do to protect against more complicated fixation attacks is whenever someone does log in, you should regenerate the session at that point. You should regenerate the session ID at that point. All right. So the idea is that if I somehow gave you that session, like for example at a conference, you may have gone up and went and gotten some coffee and left your computer next to me. I may have slid over, opened up your cookies file, and read or typed in a different session ID for like, oh, okay, I'm going to go ahead and say that there's a session cookie for Amazon.com that happens to be ABC123. And now I'm going to watch when you come back and hope that you go to Amazon.com, notice you're logged out, log in, and hey, I now know how to get your access on Amazon. As long as you regenerate the ID whenever there's any change of access level, that becomes not a problem. Because while I managed to get on your computer and say that your session ID should be ABC123, if as soon as you log into Amazon, Amazon says, thank you very much, by the way, here's your new session ID for your logged in version, then only you know that, right? I can't have given you something that you then use to become logged in on, because upon logging in, you were then handed a new ID. I would have to be sitting man in the middle, which we'll talk about later, to have any way of knowing that. In CakePHP does provide this. Cake, by default, if you're using the authentication modules, it takes care of that for you. If for some reason you needed to do this yourself because you were doing some advanced like user level things where you had like 6 different levels of users and you were managing that, of whether you were an editor or an author or a copy editor or the admin, and you were managing that, and you allowed people to switch around, you can do that by using the session renew. Here's where things get very complicated, and there's a lot of debate as to how much people need to worry about this. Personally, I worry about it a lot. Does anyone remember, not the current website that goes under this name because it is dead to me. Anybody remember dig.com, the original? Hey, I see lots of hands. I was programmer number 2 at dig.com. I was there when we went from 30,000 users to 3 million users. This was a huge problem with us because every single person out there, again, all the very bored high school kids, were trying to find a way to become Kevin Rose on that website. And so we had to protect against this constantly. So there are some additional anti-hijack measures you can put in place, because with everything we just talked about, there's still the fact that if I just start randomly guessing session IDs, there is a chance I can randomly happen to guess one that happens to be a logged in user, and hey, I just became them, right? So there are things you can do to make this harder. It's not a few lines of code, but basically you need to have a way to store everything you can about this particular user, browser, etc. combination, and make sure that between every page load that doesn't change. All right? So it ends up looking something like this. This was me collapsing a very large class down to make it fit on one screen. Yeah. These slides will be posted online later, so you can copy and paste this and play with it if you want. But if you look down through it, basically the important part down here is that second function, the hijack token. What that's doing is that it is going in and it is taking a look at the user's user agent. It is throwing in a random salt, because if anytime you're doing hashing, you should have some random salt in there. And it is looking at what time the session started. Whenever a session starts, we're keeping the timestamp of when that started, because that's something that only the person who started that session can possibly know. And we're turning that into a token. That token then gets stored in the session, and it gets sent out as a cookie. And what happens is upon every single page load, anytime someone clicks, loads the next page, we go through, we're about ready to start up the session again, you're going to do 3 things. You're going to make sure that the session had the anti-hijack token in it. You're going to make sure that the user passed a cookie that had an the anti-hijack token in it. You're going to regenerate a brand new anti-hijack token, and then you're going to make sure that all 3 of those are identical. If any of those have changed, it was someone attempting to hijack. 99% of the time. There was a mention earlier of FirePHP. If you use FirePHP, you will hate yourself once you put this on your website, because FirePHP by default changes the user agent on the fly, and therefore this will catch you up. Because typically with sessions, a session is locked to a specific browser, right? So if you've launched Safari and come to the website and you're browsing around, if suddenly the very next hit that comes using that session ID is from Firefox, that is not you, because cookies are specific to the browser. And so that's why we're checking to see if the browser is identical. Even if it comes from the same IP, it is still not you, because cookies are specific to the browser. All right. So the idea is that all three of those have to be the same at each and every point in time. All right. Like I said, FirePHP and Firebug are one of the few things that just really make this annoying. There is actually a setting in the FirePHP plugin inside of Firefox where you can say, do not change my user agent, and instead it will send a separate header to announce that your browser is FirePHP compatible, and that gets you around this. So in CakePHP, at the moment, CakePHP, as far as I can tell, and I scoured through all the source code, it doesn't do anything about this. However, if you wish to help protect against this more, there are two options. One is you can completely write a custom session handler in Cake that would do exactly those type of checks upon session startup. Or you can just use SSL. Because if you're using SSL in the first place, if you're always SSL, session hijacking pretty much goes away because it would require a ridiculous amount of effort, because basically someone's going to have to hack the SSL chain to even start going in there and trying to send things through. All right. And also I should add that by using SSL, all of your cookies should be SSL only cookies, which there is a configuration for inside of PHP as well. Because if it's all SSL only cookies, there's no way that someone can just randomly send in or randomly read a cookie from someone and attempt to hijack them. So now let's get into some of the more fun things, such as cross-site scripting. Otherwise known as XSS. It would have been known as CSS, but it seems there was already a technology called that, so people had to invent something else. So cross-site scripting is if a user hands you data that you accidentally allow to be interpreted as script. Typically this is JavaScript, but if people are using interesting browsers like IE, there's other scripts that can run. There are many, many ways this attack can happen, right? The thing to remember is that any data that you yourself did not create has to be treated as suspect, all right? Something your user submitted via a form, the user's own user agent, headers that came in with the request, all of that can be modified by the user. I have seen a attack come through via user agent because some enterprising person out there realized that if they started putting attacks in their user agents, that they would just be randomly attempting to hack the web while browsing. And they just may get lucky enough to happen onto a website where suddenly that attack works. Also, don't forget about if you're using URL rewritten strings. So if you're using pretty URLs that happen to get grabbed and used by the controller to decide where you go, that data is from the user too, because the user gets to decide what the URL is and what they've entered there. So trust nothing. And what you want to do is use the rule of FIEO. Filter input, escape output. If you do that, you are safe. Filter input is the idea of anything you get from the user, make sure it's what you ask them for, right? If you said, give me a username, username shall be alphanumeric only. Make sure it's alphanumeric or reject it. If you ask them how old they are and they don't give you a number, reject it, okay? And then escape output is how you make sure that even if you got something that was bad, it doesn't become an attack. On that note, the rest of this talk is going to be focusing solely on the escape output side, because the escape output is the true protecting you from the attack. Filter input makes sure that you have a much cleaner database and that you're not storing attacks that might happen at some point later. So I'm going to be very specifically covering the escape aspect. There are some great ways to do the filtering. PHP has its filter var stuff built in. Cake had the sanitize class, although I know that's gone away in Cake 3, and in favor of using filter var, because filter var is good stuff. So there are three types of cross-site scripting I want to go over. The first off is reflected XSS. All right? This is taking content from the user and immediately echoing it back to them. So here's our example where we are asking them for their, what's your first name? And then we're just saying, hey, thanks for telling us that, and echoing it right back to the user. The attack now is that instead of their first name, they put in a script. So let me show you this real quick. Do you want to head over to Firefox? Alright, so I've actually got the code up here. Alright, so the same thing. We're going to have a, search our website, and we have a search field. All right, can everyone read that? Do I need to make it bigger? Bigger? Good? Good? All right. So, you have a thing saying, search our website, type in your search field, and then because this isn't a real search engine, we're pretending we have a search engine, and we're just always going to say, no results found for that. Thanks so much. So if I ever go and do this, and I will search for Eli, no results found. Search for nothing. Search for cake, no results found. But if I search for alert XSS, it executes. Because that actually got put onto the page. All right. You'll notice when a lot of security talks and security researchers talk about stuff, you'll see that alert XSS used a lot because it's just a nice, very easy way to show, look, I was able to give you script and it executed. It doesn't look very scary though, because like, oh look, the user was able to just do an alert, right? But you could do an alert of document.cookie. And because my cookies were not HTTP only cookies, you're now able to see my session ID. Not only are you able to see every cookie that user has, but you're able to access absolutely anything on that page via DOM, right? You are able to run random code. So instead of like alerting stuff, you could be reading a bunch of contents off the page, like what their username is and their cookie, and then using JavaScript to send that off to another website where you're collecting all this info. Now the fact still remains, this is a case where yes, the user has to hack themselves, right? The user is entering something into a field that is causing the script to be executed against them. So theoretically, this isn't really a problem. Except users are dumb. I don't know, I used to have this screenshot, and I lost it at one point, from Facebook, where someone had posted a, like, hey everyone, there's this really cool feature on Facebook. If you type your password into a comment field, it shows up as all asterisks. And then they had put a whole bunch of asterisks. And then 2 or 3 friends who got the joke had put a comment of all asterisks, all asterisks. And then the 4th comment was someone who put, I secretly love 50 Cent. Followed by, you bastards, about 5 times. People can be talked into anything, and so you give someone a, hey, paste this into this website, this really cool thing happens. And people will do it. What's even worse is I've seen this specific attack where it was this gigantic block of like encoded JavaScript, so you had no idea what it did, and it did in fact like make some things pop up and some cool things go around and snowflakes come down from the side, and it looked like this really cool thing that people would want to tell people to go do. And in the midst of all that, it was stealing all of their information and sending it off to another server. So it is unfortunately pretty important to stop this. So the way you solve this is you have to escape it. And you have to escape it proper to the type of output that you are doing. All right? So if you are outputting to HTML, you need to use HTML entities or HTML special chars. All right? When using this, you need to make sure, you'll notice in that line that there is, the 3rd parameter is UTF-8. You must make sure that you are using the proper character set encoding, because there are some funky attacks that can happen by attackers making an assumption of, I bet the data is coming in as ISO, but going out as UTF-8, and so I can fashion this exact thing that when it tries to encode it, it actually turns it into an attack character. The 4th parameter that was added there is FOSS that I have. FOSS is a wonderful, wonderful thing to put in there. What it does is it stops double encoding. So that if you happen to pass something through HTML entities more than a couple times, it won't just keep encoding the encode and the encode, and you end up with websites that have the ampersand quote, ampersand quote, ampersand quote appearing. There are various solutions for your other outputs. Again, the point is to find the right one for what you're doing. For JavaScript, for example, there's this little bit of magic code that tends to work fairly well. You can also just JSON encode whatever you're outputting for JavaScript, and then you're safe. For XML, there's this magic incantation that I found over a decade ago and still works wonderful to this day, because HTML entities, HTML special chars are for HTML. You do that on on XML and you have problems because they will turn an ampersand into ampersand amp, which is not valid in XML. So this magic little incantation, if you're doing UTF-8 in the first place, works fairly well, which basically just tries to convert UTF-8 into UTF-8 ignore and replaces out the control characters completely. And you end up with something that is clean and safe to use for XML. In CakePHP, if you use the HTML helper methods, depending on the one, they either take care of this for you, or there's an extra parameter you can pass for escape true or escape false for whether it should be taking care of that for you. Or you can also do it yourself using H. H is simply an alias for HTML special chars, because HTML special chars is really, really long to type, and so every framework I know ends up making an H or something very similar to that. So that was reflected XSS. Stored XSS is the exact same idea, but now much worse. Because now you're storing the data in the database and later allowing it to be read and shown to a user. All right? So again, it's the exact same attack here. It's just that now instead of echoing it out, we're storing it and then later echoing it out. So I want to show you a real quick live example of this one. So this is our profile page that we have that actually says, it's someone's profile page. It's simply reading in from users, grabbing their username, and saying, welcome to that person's profile page, right, with their name. We then have this other one here. That's the form that allows us to update this particular page, right? So like I want to change what my name is. And it's just a simple form that allows us to update it. And that's coming off the screen, so there we go. And we're doing an update to set the name. And we're even doing things right here where we're using stored prepared statements so that we don't have a SQL injection, so that's great. The problem is we're still taking this raw post and putting it directly into the database. So what happens here, after I click back a few times, so here's this profile page, right? And it's just, welcome to the profile page. And I can go over here and decide that the name should be Bob. Name is now updated. Now if I come here, there we go, welcome to Bob's profile page. But if I come in here and do that, the name has now been updated to a script. When anyone comes and visits this page, that script runs. And someone who's smart about this, because the page now looks weird because it's welcome to blank's profile page, so that someone who's smart about this is going to do something like this, where they're going to put their real name in there, and then the attack. And so now if that wasn't an alert, if it was something behind the scenes, you wouldn't even know it happened. You would know that everything had just been stolen. So, the nice thing is, the solution to this is exactly the same. Escape the output. And escape it in the exact same way you would. You just need to get in that habit of anytime you're outputting anything to the user, make sure you escape it using an appropriate method. And now we get into the third type, which is kind of weird. And it's stuff happening completely in JavaScript and never touching your database at all. And so it's cases when, like in this case, this is some jQuery code where we're having someone type something in, we're reading values out of the form fields and not even bothering to submit them, and then changing the output of the page. So, we're saying, like, give us your name, you type it in, and it makes it appear without ever touching the server. All right. Yeah, I'm going to run short on time, but I can just show real quick. Nope. There we go. So this is a case where I'm saying, and that's never going to the server, it's happening all in JavaScript. And so now I can actually make the attack happen. That never comes to your server, so you cannot fix this in PHP. You have to fix this in JavaScript itself. You can write a very simple sort of function like this in JavaScript, because JavaScript, the current version, has no escaping for output built in. The next version, that's one of the next versions that's coming, I forget which version it is, but it is in the spec. But the spec got approved, and that was like 6 months ago. So give it about 5 years and you'll be able to use it. So in the meantime, you can write a function like this, but this function doesn't really work all that well. It misses a lot of stuff. The best thing to do is to use a library that'll do this for you, because to take care of, you have to escape things differently if it's going to be an attribute, if it's going to be HTML, if it's going to be CSS, etc., how you're using it, right? So there happens to be this really good one on GitHub. It's github.com/chrisisbeef/jQuery-encoder. I don't know who Chris is, but he obviously likes a lot of beef. But it actually makes it very easy to handle. All right, cross-site request forgery, or CSRF, because that's a mouthful. So CSRF is the user being able to forge a request on behalf of someone else. All right? This tends to happen very simplistically via image tags, or can be complicated via post forms, and even more complicated via JavaScript. This one's a little complicated to explain, but let me try to go through it and I'll show you a quick example. So the idea here is that the simplest version is, if you are doing something that's a GET request, right, is you will have an image. On this bad website, they will make an image tag that has width 1, height 1, so that you don't really notice it. You have to do 1, 1 if you're being evil, because 0, 0, in some browsers, they won't actually render the image, because the browser optimizes that out and goes, it won't appear anyway. But at 1, 1, it'll appear, but it'll be one little pixel and no one will notice. And you give a source that does anything you want, right? You could put any number of GET parameters in there, go off to whatever website you want, and when you come visit my website, I just made your browser make that request off to another website and submit any of that GET data that you wanted, right? You can do post via some JavaScript like this. In fact, this particular JavaScript doesn't work nowadays, but it looks like a nice simple example, because modern browsers have a fairly good cross-domain policy that won't allow JavaScript to directly talk to other servers. However, there's still ways to do that, and I'm going to show you that here in 1 second. But the idea is that you can use JavaScript to push things out to another server. The solution for this gets very, very complicated, because basically you have to make CSRF tokens. So essentially you have to make something unique that only the user properly doing the action would possibly know. So when you go to generate a form, you create a token. You hide that token in the form as a hidden field. You give that token back to the user as a session variable. And upon submission, you make sure that they had that token in the session variable, that that token got submitted via that hidden form field, and that they match. There is no way for someone forcing a request otherwise to know what that token could be, without there being multiple holes where they were able to do that, because they would have to actually be able to see the source of the page generated uniquely for you when you loaded that form to know what that was to match it up. And then this is the on submission, you have to make sure that they match up. Cake makes this very simple for you, actually. If you're using Form Helper and all the form functions, you can simply load the component CSRF, and you're good. And if you needed to actually request the token manually for any reason, you can do that via the line of code there of request param CSRF token, in case you were doing some JavaScript work that needed to make that happen. Oh, hello. Oh, that's fun. How many copies of this do I have running? There we go. All right, so I have an example here where I have this password change form where I can go in here and, no, really, I don't want to remember the password. Stop that. So I can go in here and, change my password to whatever I want it to be. So I've made this evil page over here with this big, awesome looking button that everyone would want to click, right? And I'm going to click that, and oops, what happened? I suddenly went off to this other page and changed my password to whatever this page was trying to make it happen, because it submitted the post on my behalf to the other page, right? This actually gets worse if you are on Safari, because Firefox actually protects you a little bit on this. But on Safari, I can click this, and hey, it didn't happen. What's going on? I have no idea what's going on. Well, if I actually go in here and look at this attack page, it's actually submitting this into an iframe that was hidden. So I'm going to make that iframe not be hidden. I'm going to go back in Safari and reload this page. That's what's actually happening, is it is submitting it off to the other server inside of an iframe, so you don't even notice it happened and it just changed your password. Fun times. All right. I am running a little short on time and I want to get through this here. So, clickjacking, the most evil of them all. Does anyone remember mumble years ago when Twitter was down for a couple days? Ha ha, joke. Okay. When Twitter was down for a couple days because it was completely full of like every single user posting the exact same phrase that was this like, hey everyone, come visit this cool site, and a URL. Anyone? That was the first very public clickjacking attack. Because what happened is people would click that link, go to this other website, see a button on that website that said, hey, click for cool stuff, and suddenly they had posted this back to Twitter. And so it perpetuated. The trick with clickjacking is that CSRF protection and everything around that is stopping someone else from forcing you to make a request. Clickjacking is this trick, thanks to the power of CSS, that means that no, you really made that request. You physically said post that to Twitter, even though you didn't realize you did. And it's really hard to explain, so I have this little demo that actually lines it up. So let's just say I have this evil website I've created, and I want you to click this particular button, and pretend that says win a free iPad, all right? Now there's this other website called Quacker that allows you to post what's on your mind at the moment, all right? So what if I took that website and I moved it into an iframe inside of my page? Now what if I moved that so that the button in that iframe was exactly on top of my button? And now what if I set that iframe to have opacity 0? That iframe is still on top of that button. It's just completely transparent. And now if I go and try to click that button, you're not actually clicking that button. You are clicking inside the iframe, which is sitting on top of it, and you are actually physically clicking the button on the other website without realizing it. And the worst part is, because you're clicking the button on the other website, this button doesn't actuate at all. It doesn't look like it worked, so you click it again. And that's what happened to Twitter, is everyone came to this website and went, well, what the heck, this isn't working. And then went to their Twitter feed and realized they had just posted something 100 times. The nice thing is that there is a good solution now that became a standard in October 2013. The IETF did this. It doesn't quite work in all browsers yet because it just came around in 2013. But there is a header that you can set. It's X-frame options. And you can either set deny or same origin. There is an allow, but I don't like speaking about it because you shouldn't. Basically, clickjacking only works if your site can be put into a frame. As long as you can never be in a frame, you can't be clickjacked. And it's that simple. So if you have your website echo out header frame X-frame options deny, no browser will allow your website to ever be put into an iframe. Same origin allows you to be put into an iframe only if it's on your own website, right? So if you're actually using iframes for some reason, you could still do that with same origin and still be protected. If you want to be 100% protected in all browsers, even people using very old browsers, there is this solution, but it is such a hack, I hate it. It's a little bit of JavaScript you put at the top. Basically, you tell your entire web page to display none, so your website doesn't ever display. And then you use some JavaScript to check, does self equal top, i.e. am I not in a frame? If so, oh, display the body. If not, redirect yourself one up the chain. You set top location to self location, and basically use JavaScript to step yourself out of any frames, and then only allow yourself to display when you're at the top. The drawback to this is that your website flickers. Every time someone loads the page, it is blank until the JavaScript runs and makes it happen. So, hence why the other type is much better if you can set the headers. I'm officially out of time, so a couple just real quick things. With brute force attacks, you've really only got a couple defenses: CAPTCHA or IP rate limiting. ReCAPTCHA is awesome, and I'll skip the slide for now, but just say it's awesome, and I know there's a plugin for Cake with it. Rate limiting is the idea of saying if someone's trying to bang their way through your website, you can actually put some code in place to say, like, I'm only going to allow 5 attempts per minute, or I'm only going to allow 5 clicks per minute, or something like that, and then just let them silently fail after that. And man-in-the-middle attacks, real quick, are basically the attack that happens at every conference. Who's the evil person out there? This one. But the idea that you think you're talking to another server, but in fact someone has set up a Wi-Fi hotspot that you're actually talking through, and they're monitoring every single packet that's going across it and seeing exactly what you're seeing. There is one solution to this, and it is called SSL. That's what SSL got invented for. As long as you're using SSL, the man-in-the-middle attack can't happen. One brief announcement, and then I will get down off of here. We are running PHP Architect. We are running our 2nd annual conference each year, PHP World, this fall. This year we have added a CakePHP track. And the call for papers is open for 1 more week. So if you would like to submit, we would love to get all sorts of talks about Cake. You can head over to world.phparch.com, and we would love to hear from you. And thank you very much. I will be uploading these slides to my website, eliw.com, and I will be here the rest of the day, so I know I had to rush through the end there. So please, if you have any questions, just come find me. Happy to answer anything. Thank you very much.